Okay, today's new stuff is about polynomials, day one. I guess I should have that slide up for that, but I'm going to quickly remind you about the tennis ball lab, and just a couple thoughts. You may want to take some notes here about what to do for your tennis ball lab. First of all, what does it ask you to do? The purpose, when you write out your lab, you of course are going to follow the format for all labs, and the purpose part is one of them. And you can't just copy exactly what it says. Basically, the purpose is to find the speed, and that is the vertical speed that you threw the ball at, and find the max height of the ball you threw. There is a follow-up question. You don't need to include that in your purpose, but the follow-up question is about how, if you had thrown it off the top of the roof, and the roof height was 8.2 meters, they're obviously messing with you a little bit to see if you can deal with that parabola equation once its initial height got moved up. All right, so here's your equation. And obviously getting that equation down will be a big deal. I am not going to give you the equation for yours, but we could just write a general equation for a parabola. How does it always start? Well, y equals is kind of a good thing, but could I put h of t? Well, I could have put it g of x. Yeah, that's just like the same thing as a y, right? And why am I putting h of t? Just because it sort of sounds like height. Okay, ht, but that means I'm going to use a t for my variable. And if it's a parabola, it's got to be t squared. And then how do you start these things again? Do you remember that first number? Unless you changed planets, it's always the same number. Negative 4.9, and that's in, and you don't put the meters in per second in here, but it is in meters. Okay, and why does that matter? Because then all of our measurements need to be in meters. Then, do we know the velocity at which you threw the ball? Let's call it b then. And then, do we know your starting height? I don't know it for you because that's one of the things you have to figure out, but let's say that it was 1.7 meters. Okay, then, how am I supposed to solve that for b? Because you know the time and height combination. You know the time and height combination. Okay, what's one time and height combination? At the moment you started. At the moment you started, the height was what? 1.7. So if I stick that in, height is 1.7, do you get that all of this would need to cancel to make this really true? And why does it all cancel? Because at that moment, what is the time? At the moment, you're just about to release the ball, but you haven't yet. What's time? 0. Do you get that at time 0, you have a height and you have a time, and it actually works. That solves that equation. 1.7 is equal to, cancel, 1.7. All right, there's no big revelation there. I think you know that at time 0, that the ball was at 1.7 meters. Well, then you have to just do the process kind of like that using the other time that you have. The other time that you have was when the ball hit the ground. So once you've figured out how fast you've thrown it, that's b. Once you've solved for b, then you can go on and pretty easily, using the skills you used on the last test we just took, if you have the equation, like we gave you this number on the test, we'd say it was like 10 meters per second. Once you figure out yours, then it's just like the test question. Not super hard. All right, so that's your lab. And all you need is one number, which I will give to you today in class. If you are at home and you're saying, well, I'm not in class, so I can't get the number, you can get the number. Just measure yourself in inches, do a conversion into, up to your eyeballs is where I kind of said where we would release from. And then do a conversion from the inches into meters. But I'll be able to do it a little easier in class here. Have the markings on the wall. So, all right, enough of that. Let's talk about polynomials. Oh, and by the way, when is that lab actually due? I'm going to officially put the lab due on Friday of this week. That gives you the rest of this week to finish that lab. Okay? And that's not that hard to do. Literally, if you understood what I just said, okay, maybe not Friday, but if you understood what I just said, then solving this lab should be like 15 more minutes. Literally, like 15 minutes. It's like a test question. And you already took a test, that's a lot like it. Okay, so remind me what Friday is. End of the quarter grading day thing, right? Okay, so then I will make it Monday. You can have over the weekend if you want to. All right, but if I were you, I'd get it done now while quadratics are still kind of fresh in your mind, because honestly, we're moving away from them now. This is not going to be quadratics for the next week, so you're going to get dumber. Okay, bad word, I know. Between now and when you do that, when you actually do the lab, it's going to get worse and worse the later you wait. You do it tonight, you still remember quadratics. You do it a week from now, you might be like, what was that thing I did on the calculator to find the vertex again? I don't remember how I found the highest point of the parabola. All right. So this is, I'm going to pause for a second. This is similar to the test question that we use to do our, what do you call it, linear regression. Okay, but I actually made the suggestion on this one. Why make the kids type in that many numbers into their data? Because it's just going to be a teeny bit more accurate to have more data. So we cut the data down to a smaller amount. But otherwise, you had to do a linear regression. Okay, I was amazed at how many kids had trouble with this one. It wasn't R2, but my theory is that it was just a simple, like they typed in one number wrong on their chart, and then therefore their numbers were all off. Because that's all it would take. Do you get if you made this an 11 instead of a 10? All the data is going to be off a little bit, and therefore your answer would be off. Okay, so you'll find out, I guess, for yourself whether you made that mistake. Okay, so here is polynomials. Thankfully, today is a super easy one. Basically, a polynomial is kind of like a quadratic, except it's bigger. It's got more terms. Does it have to have more terms? Technically, it doesn't. And technically, x squared plus 3x, that's a polynomial. In fact, that's our first job, is to figure out what is the definition of a polynomial. We're using this as the chance to get bigger than this, which you got used to last year, and we just had a test that involved quadratics. So if I just go to x to the third, does that make it a polynomial? No. We just change it to poly instead of like quadratic, because then poly can go for any number up there. So it could be x to the 16th. All right, so there's some things that you need to know about these. And I'm going to go through the basics. Number one, are there any rules about polynomials? Yeah, there are. And the main one that you got to look for is that the powers have to be normal. You can't have a power of 0, and you can't have a power of negative anything. So in other words, they have to be rational numbers. No, irrational numbers are numbers that can be written as a fraction. We can't have fraction exponents. We can't have, so what are the kind of numbers where they can't be fractions? Integers? No, then they can be negative. So I can't use the word integer either. What do the exponents have to be? Integers would allow negatives, can't use that. Whole numbers would allow 0, can't use that. What type of number doesn't include 0, but would include things like 1, 2, and 3, but wouldn't include things like 3.5? Do you know that word? Good, then you're getting a little bit smarter. The official word for that, the number that is going to be a counting number. Still nobody? Starts with, again, whole numbers really close. It's just you need one. Okay, fine. Natural numbers. The natural numbers. That's where you start with 1. Just think about it. When you learn to count, do you think that you started learning with 0? No, that would confuse the heck out of the kid. Here, count these. There's nothing there, Mom. Good, you learned your first number. What? No, you'd be like, you put out 3 rocks and you go 1, 2, 3. You have 3 rocks, and then you add. Eventually the kid gets up to. So anyway, the natural numbers are natural, like easy numbers, like 1, 2, 3. Yes. Good question. If you have 0 as an exponent, doesn't it equal 1? Yes, it does equal 1. So then if you had x to the 0, then you just have y equals 1. Okay, and is that a polynomial? Does that look like a polynomial to you? That doesn't look like a poly anything. All right. But that's a polynomial. Basically, the exponent on it needs to be one of those natural numbers, one of those counting numbers. So could I say to the third? Sure, that's fine. Could I say to the first? Yeah, that's fine. Can I say to the 0? No, then I can't do that. And also, can I say fraction powers? Nope, can't do that. And lastly, can I say negative powers? Nope, can't do that. Then they wouldn't be polynomials. All right, one more rule about polynomials is that their domain has to be all reals. I want you to think about that for a second. If I had allowed this, do you get that's the same as 5 over x to the third? And do you get the domain of that isn't all reals? What's the one thing that would crash this? Is there an x that would crash it? Yes, and therefore it can't be a polynomial. That's another way to think of it, is if there's a way to crash this function, then it can't be a polynomial. Here's another example of that. Do you get that that means the square root of x? Have you put that together yet? That a fraction power like that means the square root of? Okay. Do you get then that the domain of this isn't all reals? Because I can crash this function. So that's the thing about polynomials, is you can't crash them. So this is not a polynomial because I can crash it by putting in certain things. All right? So polynomials have a domain of all reals. In other words, you can't crash them. All right. Enough about polynomials. This is an application question that we're going to get to and spend a lot more time on later. This is called the classic box problem. I'd like you to think about just this side of the box. It says it's 10 inches, but when you fold on the dotted lines, do you get that it'll have to go less than 10 inches? Otherwise, you didn't fold off anything. So therefore, that side isn't 10 anymore. It's 10 minus something. And the classic mistake is to say, oh, it's 10 minus x. Nope. What do you think? 10 minus 2x, because there's an x you're subtracting here and an x you're subtracting there. So it's 10 minus 2x. Okay, if you go this way, it seems like it's 12. Common mistake is 12 minus the x, because they think, oh yeah, I got to subtract this off, but they forget about the other one. So what's this side actually? 12 minus 2x. Okay, so then I got 12 minus 2x, 10 minus 2x, and then last thing is on this tricky on this problem is that you don't realize that there's a third dimension. Because you've now folded this up into a box, do you get it now has a height? And so therefore, if it's length times width times height gives you the volume of said box, I know the length. I usually use the longer one for length. I know the width, but I don't know the height. But I do know the height in terms of a variable. It's x. So then this is the length is the longer one, 12 minus 2x. The width is the next one, 10 minus 2x. And the height is just x. Do you get if I multiply that all out, I got myself a polynomial? Does that make sense to you? I now have a polynomial for a box. And what does length times width times height do? It gives you the volume. So it's the volume. It's a great example of a volume polynomial. And what does it all depend on? X. And what is x? X is how tall you want to make your box. If you're a baker and you're trying to set up your box, you might want to make it high enough so it doesn't squish your cupcakes, but not ludicrously high so you have lots of extra wasted space, right? So you might want to set them and figure out how tall the typical cupcake is, and then anyway, here's your formula, cupcake makers. All right, enough about that. Let's talk about in polynomials. We have end behavior, which is basically the right and left end of the polynomial. Here's my polynomial. What's it doing on the ends? Do you get on one end it's going up and the other end it's going down? Except we say that in a more fancy way. It's increasing on the right side and it's, no, but it's not decreasing on the left side. No, it's not even going down on the, well, you would use the word it is down on the left, but think about it. In this little zone here, do you get how it's tempting to say it's decreasing, but we don't read from right to left. It's actually increasing in that zone, isn't it? You know what I'm saying? Thinking really fast will not fix the problem. All right, so this is down on the left, but it's not decreasing. It's a big difference. It's actually an interval over which it's increasing. See, it's going up as I go this way, and we always go from left to right. Okay, so it's down on the right and up, sorry, down on the left and up on the right. So I know something about this function. I know that its equation, whatever its equation would be, I can tell you two things about it. Number one, I can tell you that it leads with a positive. The number in front here has to be positive. Why? Because it's up on the right. You've probably never put that together before, but every single quadratic that we did, if it was positive, it was up on the right. And you might be just thinking, well, it was up on both ends. Yes, but it was up on the right, and that's going to stay consistent even when the polynomials do different things on the left side. The right side, you can tell, I can make it really complicated here, but all I really need to look at is the right side to tell the lead coefficient. This equation must start with, what do you think? Negative. It's going to be negative x to the something. And now, we'll teach you more about how to figure out what that power is. I can tell you right now that since it has 1, 2, 3 terms in it, then it's probably a degree 4, as in this power is probably a 4. But I'm going to teach you more about exactly how to do that later. For right now, all I need you to know is if it leads with a negative, the right-hand side's going down. All right, next thing. If it has a power on this lead term that is like a 5, that's an odd number, right? Odd number ones, their ends do different things. This one's down and down. Therefore, it has to be an even number up there. Like I said before, it's probably a degree 4, but it could actually be a degree 6 or a degree 8. The moral of the story is that power tells you whether the ends are the same or different. And if it has an odd number right here, then they're different. If it's even, then they're the same end behavior. And if they're odd, then it's different on the ends. So, tell me something you know about the equation for this thing. Is it positive or negative in front? Positive in front. Do I have to put a plus? No, it would kind of be assumed. And then, could it be like a 2? We don't know yet. We don't know how to find the stretch factors yet, but it could be. Could it be x to the 5th for this one? It could be. It could be any odd number because they're going in opposite directions. So I can tell whether they're the same or different based on that being odd or even. I can tell that the right-hand side is up or down based on that being positive or negative. So let me ask this. Could this possibly be the start of this equation? Yes or no? I can tell you 2 reasons that that's wrong. I can at least tell you one for sure. Do you get why? Give me one reason that equation can't be right. Yes. If it's negative, this would have to be going down on this side. Okay, good. All right, how about this one? X to the 5th. Could that possibly be the right equation for this one? Yes, because they're going opposite directions and it's odd. How about if I change it to x to the 15th? Could it still possibly be right? Yes, it could. How about if I make it negative in front? No. All right. What if I make it negative in front, but I make this end go down? But now it says to the 15th, and they're supposed to be going different directions. So no, that couldn't be right. Could it be to the negative 16th then? Yes, it could. Okay, good. You've learned what you need to know about that. Let's get into your homework. And your homework is right here. I want to show you the first few problems. I'm going to ask you about the degree. I hope I've talked to you enough about this in the past, but it probably bears repeating. That is not a degree 7 polynomial. What is it? Degree what? It's not a degree 8 either. There is a 1 there, but nope. It's just the biggest one. That's how you tell the degree, is it will be the biggest one. All right, the leading term is the one that's got the biggest one on it. Now, sometimes they mess with you, and they put the biggest one, like, at the end. They're not supposed to, but they sometimes do, just to see if you're paying attention. Do you get how this could have been x to the 17th right there? And then this is actually supposed to be in front, and it would be considered the lead coefficient. The lead coefficient is supposed to be in front, but it's defined as the one that has the biggest power is the leading term. So in this case, the leading term is 3x to the 5th. Its degree is 5. Its leading coefficient is the number in front of the variable. So what is the leading coefficient? 3. The constant term. Again, I'm hoping these are all review from higher algebra, but do you know which of those 4 terms is the constant term? The one that doesn't have a variable. That'll stay the same, right? No matter what. That's constant. So the constant is a 1. The left end behavior. Okay, think for a second. If this had a picture, the left end's over here. I encourage you to stop. It's a trap. Don't try to do the left end behavior first. First, figure out what the right end behavior is. Do you get that since this is positive, the right end has to be going up? So put up for this. Then the left end is either going to be the same or different than that. Do you get what I'm saying? Now that I know the right end's got to be going up because this is positive, then that tells me, it's an odd one. Odd means different, and therefore it's going to be a different behavior than up, and therefore down. I'll say that again. If this is an odd, if the main term, the one that's the biggest, is odd, then the ends will always be different. Okay, good. I did the first one for you. And I know you might be thinking, great, I wish you would have done number 5. Just because it's got a few scarier things in it doesn't change anything. It's still the biggest one is first. Do you get that that's the biggest term? And therefore it will tell you the lead coefficient. Whether or not it's positive is going to set the right end. Its constant is still, it's weird, but it doesn't have an x on it. That's why it's the constant. All right, and then this last one, here's the trick. You don't have to multiply it all the way out to get this. But do you get if I did multiply it all the way out, I would have an x to the something in it? X to the 4th. X to the 4th. Would there be a negative on that x to the 4th? It came from this times this times this times this. Does it look like there's any negatives on those? Therefore, it's positive. Its lead coefficient would be positive. And that's all you got to do is figure out the lead coefficient. Do you get if I got that? I already know both ends. All right. So do those. This page, I've given you some help to get started. This is a blast from the past. They're saying take x cubed and do that to it. Do you get that they've asked you to move it 2 to the, which way? 2 to the left. And where are you going to shift your x to the 3rd, which, by the way, in case you forgot, it looks like this. Where are you going to shift your x to the 3rd besides 2 to the left and then what? +1 means move it up 1. And it'll look something like that. It's just in the context of Now that you know what a polynomial is, we're going to take these polynomials and move them around. But you might not know what x to the fourth looks like, the parent for x to the fourth. So I need to start telling you that. Do you get that x to the thirds, or the fifths, or the sevenths, or the ninth all look like that? And x squareds, you know what x squared looks like, right? Take a wild guess what x to the fourth kind of looks like. It's the same thing except steeper. X to the fourth, just try graphing it at home when you're bored. X to the fourth, it's a really tight parabola. What do you think x to the sixth is? Even tighter parabola. See what I'm saying? They all look like parabolas. 2, 4, 6, 8, 10, 12, 14, 16, forever, they just look like parabolas. Okay? If they're odd ones, 1, 3, okay, 1 is the one exception. X to the 1 doesn't look like this. X to the 1, y equals x looks like that. But once they start getting a curve in them, the curve gets tighter and tighter and tighter. But x to the third, x to the fifth, x to the seventh, they all look kind of like x to the third. Okay, so I say that because that, x to the fourth, that basically is a really tight parabola that's then going to get moved here and stretched even more and flipped. And what's that? That's like a +2 at the end. I'd put it over here. It'd be a lot easier. All right, you may skip 25. (32), even though it will be a good problem when you're ready for it, I don't feel like you need it yet. Wow, this is way more dense than I thought it was. Yeah. I think, where am I going to stop? I'm going to pause for a second. I'll figure that out. Okay, solved that. The assignment actually ends right here, and I'm going to see how much of this should you be able to do. This would be a great challenge, but I'm going to call it a challenge question. But you should be able to solve this one. Hint, how do you clear, actually, you don't know how to solve that yet. You'd be able to clear the fraction, though. So how about this? On 7a, all I want you to do is clear the fraction. By now, you should remember, okay, if there's a fraction, how do I get rid of it? Clear that fraction. Okay, and then yeah, I don't think you're ready for 6. Let's skip 6. Talk more about that stuff tomorrow. Okay, that's all I got for you for today.